In this video we're going to be looking at compound interest in the context of the CFA Level 1 curriculum. This is part of Reading 6, Time Value of Money, in the Quantitative Methods chapter, and we're focusing on Learning Outcome D for compound interest and applying it to a range of time value of money problems. So we're required to be able to solve time value of money problems for different frequencies of compounding. That's the aim of this learning objective. Compounding allows us to earn interest on interest, and although interest earned on the principal is important, interest earned on reinvested interest is a far more powerful force. This is because it grows in size each period, and the magnitude of this effect increases with the interest rate, which is important to note. So the higher the interest rate, the greater the compounding effect. Just some terms that we're going to define before we move on. We have PV, which equals the present value, FV, which is the future value, R is the interest rate, and it ends the number of periods. So if you think about it on a timeline, we're at the present time, time equals 0. We haven't moved anywhere in time yet. So we have the present value of our funds. If we move along this timeline to some future point in time, let's say t is equal to 3, then we would like to find out our future value of our money at that point in time. There's some years in between, year 1 and year 2, so these are our periods as we move between them. So our n would be 3 in this case as we move to year 3. This sort of leads to our compound interest formula, where the future value at time n is equal to the present value multiplied by 1 plus the annual stated interest rate r raised to the power of n periods. So it's probably easiest to further reinforce this concept and explain it through some problem examples based on sort of CFA Level 1 exam style questions. Let's just first compare those simple and compound interest before we move into the questions. So as you can see, simple interest monetary balance increases at a constant rate, whereas the compound interest increases at more of an exponential rate. As you can see, as we move out in time here, let's imagine this was time equals 5 years, our compound interest amount diverges substantially away from our simple interest amount. So that's the power of compounding. And a bit of a quote there: compound interest is the 8th wonder of the world. He who understands it earns it, he who doesn't pays it. By Albert Einstein. So moving on to our first question. We have $5,000 to start with, so this is our present value, essentially. We're putting it into a 5-year certificate of deposit, which is essentially a savings mechanism at a local financial institution. They're going to pay us 7% compounded annually, which is quite important. Interest earned is also reinvested, so we're looking at compound interest here. How much we have at the end of 5 years, assuming that 7% rate, which is our interest rate, and no withdrawals taking place. So if we refer back to our formula, the future value equals the PV compounded by our R. So our PV is 500. 1 plus our rate of 7% for a period of 5 years to the power of 5. And that, if you calculate that on a calculator, 5,000 is our starting balance. It's going to give you an amount just under $7,013. So rounding factored into that, our answer is going to be B, 7,013. Question 2. We have $1,000 to start off with. We're investing it in a term deposit at a quoted interest rate of 5%, compounded quarterly this time, for a period of 3 years. So before we do anything, we're actually going to have to take into account this quarterly compounding that's occurring here. So if we're compounding at 5% per year, there are 4 quarters within a year. So we're actually earning interest at a rate of 1.25% per quarter. And over the course of 3 years, there are 4 quarters in a year. So we're earning that interest over 12 quarters worth of time, or that's our periods. So we have a slightly different compounding formula here. R on N is basically we're taking this annual interest rate and turning it into a quarterly rate, which is what we've done. So R on N just equals this 1.25. And then our new N is going to be for our 12 quarter or 3 year period that we're compounding for. So our future value is going to equal our present value. 1 plus 1.25% raised to the power of 12. And then when you type that in on a calculator, you're going to get a figure that's 1161. So our answer is going to be C. A pension fund estimates that his corporate sponsor will make a $10 million contribution 5 years from now. The rate of return on assets is estimated to be at 9% per year. So that's going to be our R. The pension fund manager wants to calculate the future value of this contribution 15 years from now, which is the date at which the funds will be distributed. What is the future value? So if we look at this from a timeline perspective, we're going to get a contribution in 5 years' time at t equals to 5, and we wanted to find out its future value at 15 years. So we're only going to compound for this 10-year period in between, because we haven't received the money yet, and we're not going to receive it for 5 years. So if we compounded it for 15 years, we're going to be overestimating what we've got. So we only need to compound it for 10. So just be careful with these questions and how they're worded and the timelines that you need to use. So it's always helpful to actually just physically draw out a quick timeline and see what's happening with the cash flows. So we have our compounding formula here, our trusty compounding formula that we're going to use. So our future value is equal to 10 million, which is our present value, I guess, working out of t equals 5. Multiply that by 1 plus the rate of 9%, and we're compounding it for 10 years. That's going to give us a figure. It should be just over 20 million. If you put that in the calculator, we're going to get 23,673,636 and 75 cents, right? So about 23.7 million is going to be our value at the end of that 10-year period. So that just goes to show we've got that 10 million, and 10 years later it's now over 23 million, the power of that compound rate of return. The final question, suppose the corporate sponsor from question 3 wants to set aside some amount of money today in order to meet that $10 million contribution that we discussed in 5 years' time. The corporate sponsor earns a rate of 3% on their money, and they can do that through this 5-year certificate of deposit. So basically what we want to know is how much the corporate sponsor is going to need to set aside today, earning 3%, to generate that $10 million that they need in 5 years' time. So to do that, we can take our compounding formula and actually rearrange it slightly, because if we draw that out on our timeline, want 5 years, $10 million, and we need to know, or we want to work out the present value that we need today to get to that at a rate of 3%. So we can rearrange, we divide by this 1 plus r to the power n, and then we can get our PV, which is going to equal our future value that we require of 10 million, divided by 1 plus 0.03 to the power of 5. And this process is actually known as discounting. So we're discounting this cash flow of $10 million and trying to calculate it via the discounting process to a present value figure in today's terms. And so if you do discount that amount of 10 million by 3% for 5 years, you're going to get an amount that is approximately equal to 8,626,087 $84, right? Okay, so approximately 8.63 million is what is going to be needed to set that aside today in order to get $10 million in 5 years' time at that 3% interest rate. And so that's how we can look at compounding in reverse and use a discounting process to work out the present value. So I hope you found that informative and understand a little bit about compound interest and how it can be applied in a wide variety of time value of money situations. And if you have any questions, feel free to comment below. Thanks for watching.